So those are the two tricky rules. The power rule has this exception that you can't use a power of -1 because that becomes the 1 over x rule. And the 1 over x rule has this weird thing where you need to add an absolute value that you wouldn't have expected to be there from the derivative rules. The rest of them are much simpler. What's the integral of e to the x? Can you name a function whose derivative is e to the x? You sure can. It's e to the x. The integral of e to the x dx is e to the x plus c. Join the long tradition of calculus students who noticed that it looks like I just wrote the word sex down. What's the integral of a to the x? I know the derivative of a to the x is almost a to the x, but there's this extra natural log a out front. So my integral is going to be almost a to the x, but when I take the derivative, I'm going to get an extra natural log a out front. I put a 1 over ln a to cancel that. Remember, natural log a is a constant, so 1 over log a is a constant. This is a constant out front, doesn't mess up the derivative. If the thing was a function of x, dividing by that would suddenly need a product rule or something. Derivative of this doesn't need a product rule. The ln a will cancel with an ln a. I know the derivative of sine x is cosine x. What's the integral of sine x? Do I know something whose derivative is sine x? I know cosine, whose derivative is almost sine, but off by a minus sign. Well, if the derivative of cosine is negative sine, then the derivative of negative cosine will be sine. And the integral of cosine x is just sine x with no trickiness. These are the integration rules, the basic integration rules. They are basically the derivative rules backwards, and you mess with some constants to deal with that. Let's try this out. Say I hand you the integral of x squared minus 4x plus 9 dx. This is 3 basic functions added and subtracted together. The integral is going to be, what is the integral of each of them? Keep the minus and the pluses the same. Do I know the integrals of each of these things? Well, this is x to the 2. The power rule says I need to add 1 to the exponent. That'll give me x to the 3. Divide by that new exponent out front. So the integral of x squared is 1/3 x cubed. Minus, I need the integral of 4x. It might help me to write this as an x to the 1 to remember that the power rule still kicks in. I'm supposed to add 1 to the exponent, x to the 2, divide by that new exponent out front, divide by 2. The 4 out front was a constant out front, can stay out front. Usually you put it up on top of the fraction. I guess usually you would do 4 over 2 in your head and just write down the 2. Plus, what's the integral of 9? This looks the least like the power rule. I can make it like the power rule by writing integral of x to the 0. Remember, x to the 0 is 1. Power rule says add 1, get x to the 1 over 1. But that's sort of overkill. I know the derivative of x is 1. The derivative of a constant multiple of x is that constant. So the integral of any constant is that constant multiple of x. This is a form of the power rule, is why it's only getting a little side box over here. And it's worth remembering. The integral of a constant is that constant times x. So the integral of 9 is 9x. And at the end, we put a plus c. There's the integral. 4 over 2 reduces, so I could rewrite that with the whatever. Yeah. Let's try another messier one. If I want the integral of 1 over x squared minus the cube root of x plus 1 over x minus e to the x plus 2 times 4 to the x dx. What is the integral of this? Just like with derivatives, there are things that can turn into exponents that don't look like exponents. This 1 over x squared is basically a power of x. I'm going to rewrite that as x to the negative 2. This cube root is a power of x. That's x to the 1/3. This 1 over x is x to the negative 1. There's nothing to do with these other guys. Just like with derivatives, you want to make sure you do all the stuff at the same time. Like I have been rewriting, not integrating yet. So I want to keep the integral and the dx here to indicate that I still need to integrate the thing. And in particular, I want to make sure I'm not integrating these pieces as I do it. Even though I kind of did integrate e to the x, because not doing anything is integrating for e to the x. Now what do I need to do? I need to add 1 to these exponents. Negative 2 plus 1 is x to the negative 1. And I need to divide by that new exponent out front, 1 over negative 1. Minus, add 1 to this exponent. What's 1/3 plus 1? 1/3 plus 1 is 3/3, makes 4/3. Just like you got pretty good at subtracting 1 from a fraction in your head during derivatives, you're going to get pretty good at adding 1 to a fraction in your head now. I need to divide by that number out front. I would put 1 over 4/3. You want to get the hang of 1 over a fraction is its reciprocal. The thing that goes out front is 3/4. X to the negative 1. What do I get when I add 1 to the exponent? I get x to the 0. Divide by that number out front. Whoa! Can't divide by 0. Something's wrong. This is the place where the power rule doesn't work. X to the negative 1 was 1 over x. I don't need the power rule for 1 over x because I know a function whose derivative is 1 over x. It's natural log of x, and I need the absolute value as the weird extra thing. Minus, what's the integral of e to the x? It's e to the x. Plus, what's the integral of 2 times 4 to the x? 2 is a constant out front, stays out front. Ignore the 2, or write it down when you're done. What's the integral of 4 to the x? The derivative of 4 to the x is 4 to the x multiplied by natural log 4. So the integral is 4 to the x divided by natural log 4. And the 2's should still be there. I'll stick it on top of the fraction. And I need a plus c. There we go. When you do these problems, I highly recommend that after you do the integral, you take the derivative. I didn't do it on the first one, and I should have. That was my big chance to tell you you should do this. The reason I'm saying this isn't just for the practice. The reason is these integration rules feel a lot like the derivative rules. They are easy to mix up. You want to keep them both straight in your head, and I think this alternating between do an integral, now do the same derivative is really good for helping make sure you keep your derivative rules, which you're going to want going into the final, and keep them separate in your head from the integration rules where they're almost the same. Like the worst version of this is the sine-cosine thing, where these are kind of the same rules. They both have a minus sign somewhere, but where the minus sign is in an opposite place. Like, that's rough. And you want to be keeping stuff like this straight. So I'm going to take what's the derivative of this. The derivative of this is the 3 comes out with the 1/3, cancels, gives me x squared, minus this number is 2. A 2 comes out, front times 2 is 4x. Derivative of 9x is 9. Derivative of a constant is 0. Hey, look, this is what I was supposed to get. Remember, the thing we're doing with the integral is finding a thing whose derivative is this. Because we're really good at looking at a function and writing down its derivative, we're really good at checking our answers on this stuff. Like, every antiderivative that we find should be a really easy thing to check our answer if we've still got our gateway skills. Does this work? Actually, let me simplify. Well, the thing to simplify is 1 over negative 1 is negative. So this is negative x to the negative 1. What's the derivative of all this? I get negative 1 times negative makes positive x to the negative 2, minus 4/3 comes out front. 4/3 times 3/4 is 1. X to the 4/3 minus 1 is 1/3. Derivative of natural log x is 1 over x. This is the place where it feels a little different from the gateway. We never really took the derivative of natural log absolute value x, just sort of know from this observation that that is a plus or minus x, and either way the answer is 1 over x. The derivative of natural log absolute value x is 1 over x. Minus derivative of e to the x is e to the x. Plus 2 over natural log 4 is a weird constant out front. Derivative of 4 to the x is ln 4, 4 to the x. Cancel, cancel. Plus derivative of a constant is 0. I got doop, 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 doop. This is what I was supposed to get. Cool.